Let's think back. When two triangles are stated to be congruent. So let's think about that. When triangles are stated to be congruent, what can be concluded? Do you need a visual? Well, let's look at the following figure. It says that triangle PQR is congruent to triangle PLM. The congruent statement tells us that. The picture doesn't tell us that because there are no marks here to tell us what's congruent. But the statement, because the triangles are congruent, we can conclude things like angle R is congruent to angle M. So we can mark the picture that angle R is congruent to angle M. So we can say, because of this statement, therefore, angle R is congruent to angle M. What else can be concluded from this statement? Well, angle Q is congruent to angle L. Angle Q is congruent to angle L. Another thing that can be concluded, angle Q congruent to angle L. How about any of the sides? Sure, anything that corresponds. Segment PQ is congruent to segment PL. Segment PQ is congruent to segment PL. Another thing we can conclude, segment PQ is congruent to segment PL. All of the parts that correspond from one triangle to the next must be congruent. So that's ultimately what we can say when two triangles are stated to be congruent. We can say that the corresponding parts of the congruent triangles are congruent. Remember, corresponding means matching parts. So these corresponding parts, the matching parts, the corresponding parts, the parts in the same positions of the congruent triangles, that's what we're given to start with, triangle something congruent to triangle something else, are congruent. Now we like to abbreviate this CPCTC for short, but ultimately you really do need to understand what these letters stand for. Corresponding parts of congruent triangles are congruent. Memorize this. Let's take a look at how we can use this. Complete each proof. So in number 1, we're going to be proving the base angles theorem. We're given segment HI congruent to segment HK, and segment HJ bisects segment IK. Remember, we always mark this given information in our picture first, and we always state it in our proof first because it's what we're using. So I'm going to state everything that's given. Basically, I'm just rewriting it here because it's the logical order of what I'm using. I didn't have to think of it, it was given to me, and I mark it in the picture. HI congruent to HK, and HJ bisects IK. Now, how do I show that a segment is bisecting another segment? Well, what does bisect mean? Bisect means to cut in two congruent segments. Cut it in half. Cut it in the middle, at its midpoint. So how do I show that J is the midpoint? I mark this piece congruent to this piece. Now that wasn't given to me that these were congruent. We had to remember that that's what bisect means. So according to the definition of bisect or segment bisector, IJ is congruent to KJ. So that's what we're stating next. Segment IJ is congruent to segment KJ because of the definition of bisect. What else can we use here? Well, these two triangles share a side. So I'm going to use the reflexive property next, the shared side, to say that that segment is congruent to itself. HJ is congruent to HJ. Now remember, always look at our goal. Where are we headed? We're trying to prove that angles are congruent. But remember what we said earlier. If we know that triangles are congruent, we can conclude any of the corresponding parts congruent that we want to. So let's try to get triangles to be congruent. Do I have congruent triangles in this picture yet? I sure do. Let's focus on one of the triangles, maybe the top one. So noticing that this triangle has all the same marks as this triangle, we can use our postulate side, side, side to prove that those triangles are congruent. Let's make that statement. Triangle HIJ is congruent to triangle HKJ. Now that's not our ultimate goal to prove the triangles are congruent, but now that we've proved it, we can say this, that angle I is congruent to angle K. See how they're in corresponding positions? So we're going to say corresponding parts of congruent triangles are congruent, or CPCTC for short, as long as you know what it means. Now I want you to notice this comes after saying triangles are congruent, always after one of our congruence theorems. Let's look at a couple more. Given all of this information right here, let's restate it and let's mark it in our picture. Angle B is congruent to angle E, segment FE congruent to segment BC, and they are also parallel segments. So I'll put the arrows showing they're going in the same direction. And then we'll write all of it here. And remember, we didn't have to think of it. It was given to us. Why did we mark it? Because it was given information. Now let's figure out what can we use to help us get to what we're trying to prove. Angles are congruent. If we're trying to prove parts, first we want to think prove triangles congruent. That's what we want to do first. So do I have enough information yet to prove the triangles are congruent? An angle mark and a side mark. Nope, that's just two things. We need something else. Well, the parallel lines. Remember how we can use the zigzag shape to get alternate interior angles? There's my zigzag shape right there, so I can say this angle congruent to this angle. Now, if I just say C, it's a little ambiguous. Which C do I mean? So I'm going to use the three-letter name, BCF. Angle BCF is congruent to angle EFC. Angle EFC. And the reason? Well, not zigzag shape. The real name is alternate interior angles. That's anytime we have the zigzag shape. So we've got that. Now do we have enough information? Well, let's see. In this top triangle, I have an angle mark, side congruent mark, angle mark. So I do angle, side angle to say which triangles are congruent. BCA is congruent to triangle. Let's make sure we match them up. Single slash, double slash. Single slash, double slash goes EFD. Now that I've said the triangles are congruent, I can say these parts. What I want to prove is angle A is congruent to angle D. Are those in corresponding positions? They sure are. Same places. So since they're in corresponding positions, corresponding parts of congruent triangles are congruent. Let's look at one more. Given information, we always state that first and mark it in our picture and use it. It was given to us. We didn't have to come up with it. Let's put it in our picture. TM congruent to MR. JM perpendicular to TR. How do I use perpendicular? How do I show it in the picture? Well, what does perpendicular mean? Perpendicular means that the lines intersect at a right angle. So how do we show that? In the picture, we're going to mark it with the right angle symbol. But I have to state that I came up with that because I knew what perpendicular means. That is the definition of perpendicular lines. Perpendicular lines means they intersect at a right angle. So I'm going to say that angle JMT and angle JMR are right angles. Angle JMT and angle JMR are right angles because I know that's what perpendicular means. They're making a right angle. Now, I'm trying to prove these segments are congruent, but I've got to get the triangles to be congruent so I can do that. So if I look at one triangle, notice I only have a side and an angle mark. Not enough information. Let's try to mark more things. How about this shared side? Reflexive property? You betcha. Let's mark that we're using the reflexive property because that's our shared side, and segment JM will be congruent to segment JM itself. Now we have enough information. So now, looking at one of the triangles, I can use SAS. Side angle side tells me triangle JMT is congruent to triangle JMR. Now that I've said that, I've got my corresponding parts. JT, and JR are congruent segments. Segment JT congruent to segment JR because corresponding parts of congruent triangles are congruent. Yay! Do you notice a pattern? We always use CPCTC after a congruence postulate or theorem. So first we say the triangles are congruent, then CPCTC. Previous proof, triangle congruence postulate, then CPCTC. First one, triangle congruence postulate, then CPCTC. Make yourself a note of that. We always use corresponding parts of congruent triangles or congruent after congruent triangle theorem or postulate. And put some more stars and highlight that. Awesome.